Hello students, in my last lecture I had explained refraction of light through convex and concave lenses, and we had seen that convex lenses are called converging lens and concave lenses are called diverging lens. So now today we shall see image formation by lenses. As we had seen, for image formation by spherical mirrors, rays follow certain rules. Similarly, for image formation by spherical lenses, rays of light follow certain rules. So here are four very important rules we shall see one by one, and out of these any two rule will be applicable for image formation by all concave and convex lenses. So see, first of all, what is the first situation? First situation is that if a ray of light incident at any convex lens, this is principal axis, this is optical center, suppose this is F1, this is F2. So first case states that rays of light parallel to the principal axis after refraction, this is the direction arrow, this arrow gives us direction, so this is incident ray. After refraction, one thing more important, see from which portion of the lens refraction takes place, nearly from its middle part. So try to bend the path of ray of light from the central part of the lens. So after refraction, it passes through its focus. So once again see, rays of light parallel to the principal axis after refraction pass through its focus for convex lens. This situation is for convex lens. Now see what happens for concave lens. In the same situation, if suppose we have a concave lens, this is optical center, this is principal axis, suppose this is focus 1, this is focus 2, then what happens in this case? Rays of light parallel to the principal axis after refraction from concave lens, this is concave lens, diverge in such a way that it appears to come out from a point. So here it is virtual event. It appears to come out from a point, and this point is called focus. One thing is very important here, students. We represent real rays with complete line and virtual rays with dotted line. So this is virtual event here. Once again see, in the case of convex lens, rays of light parallel to the principal axis after refraction really meet at a point on the principal axis, and this point is focus. But in the case of concave lens, rays of light parallel to the principal axis after refraction diverge in such a way that it appears to come out from a point, and this point is called here focus. So this lens is here concave lens. This was rule first. Now second rule, there are four special cases, and as we learn certain formulas to solve problems in different branch of our mathematics, similarly to trace ray diagrams for image formation by spherical lenses, there are certain rules, and here we are seeing all the four rules. Out of these four, always we shall follow any two rule according to our situation. So see, rule number 2 or situation 2. Suppose we have a convex lens. This is our convex lens. This is optical center. This is principal axis. What happens in this case? Suppose this is focus 1. This is focus 2. So, if rays of light incident at convex lens passing through its focus, then what happens? After refraction, these rays become parallel to the principal axis. Here, this ray become parallel to the principal axis. Here, this is convex lens. Once again, what happens in this case for concave lens? See, we have a concave lens here. Concave lens. Suppose this is optical center. This is principal axis. This is our principal axis. This is optical center. Optical center. Focus 1, focus 2. So, if any ray of light incident on concave lens in such a way, see here, in such a way that it appears to pass through its focus. This is complete virtual event here. It appears to pass. Then what happens? After refraction, it becomes parallel to the principal axis. This ray of light ends from this position. So this is here incident ray. This is incident ray and this is refracted ray. Here it is virtual event. It appears to pass through its focus. Then after refraction, this ray becomes parallel to the principal axis. Now, situation 3. Suppose, once again, we have convex lens. This is optical center. This is our principal axis. Optical center. This is focus 1. This is focus 2. Now, if rays of light pass through optical center, in the case of convex lens, then there is not any change in path of light. Once again we recite, I had stated you, whether it is reflection or refraction. In the case of reflection, once again we recite our previous lesson. See what we had seen. We had seen, suppose we have any plane mirror or any mirror. Suppose this is our mirror. Here we take plane mirror for our simplicity. And if a beam of light incident normally here, then what happens? After normal incidence, it retraces its path after reflection. And for refraction, I had stated in, suppose this is any glass slab. Suppose we have a glass slab. This is glass slab. This is glass slab. And a beam of light incidents here normally. Then what happens? We see that there is not any change in path of light. So whether it is the case of reflection or it is refraction, to change path, rays of light should incident obliquely. If there is normal incidence, then in the case of reflection, it retraces its path, and in the case of refraction, rays of light pass through one transparent medium to another without changing its path. So here is not any change in path of light. The same rule is followed here. So now what is the conclusion? We can say that if rays of light incident normally, once again consider geometry. What we have learnt in geometry? In geometry we have learnt that line passing through center of any circle becomes normal to any point of the circumference. Similarly, In the case of a spherical lens, this is part of a sphere, and if rays of light incident normally here, then there is not any change in path of light. Now see for the case of concave lens. Suppose this is our concave lens, this is optical center, this is our principal axis. Once here also, in the case of concave lens also, if rays of light pass through its optical center, then there is not any change in path of light, and rays of light move on its original path in one direction. So, out of these three, we can use any two rules to represent image formation for spherical lenses. Now, we shall see one by one image formation by concave lens and convex lens. So, dear students, in our next lecture, we shall see image formation first by convex lens, and then we shall see image formation by concave lens. We shall see also the uses of convex lens and concave lens. So, before concluding my lesson, I give you some homework, and I have repeated it many times that really to learn is something different to just watch video. So our motto should be real learning. So to learn, pause videos, revise it again and again, and try to trace all rays diagram which I have explained here without any help, and you may achieve this success if you are really interested to learn physics. So, what is homework? Draw ray diagrams for image formation by spherical lenses. That is, draw all these three situations: case number 1, case number 2, and case number 3, both for convex and concave lenses. Thank you very much.